Welcome to the demonstration of our final year project. This is the setup we have made for the demonstration. We are demonstrating the proof of concept using 2-axis drawing board. This is the XML file we have created for our demonstration. Let's see how the actual setup is interpreted in XML file. For the ease of explanation, I will explain the setup using a block diagram. As you can see here, our master and slave devices are connected with Ethernet 100 base TX. Master and PC is connected with USB cable. We have clustered the slave devices which belongs to particular motion by giving them a cluster number. Initially, the user can configure the system by using XML file. First, under the slaves tag, we are describing all the slave devices presented in the system. As you can see, slave number 1 belongs to cluster number 2. Then the slave number 5 belongs to cluster number 4. There is this motor M1 which is driven by slave number 5. Therefore, its parameters are given under servo parameters tag in the XML file. Then the slave number 6 is also belongs to cluster number 4 and motor M2 is driven by it. In the next section of the XML file, it describes the emergency details of the system. First, we have described the emergency details of cluster 4. Under servo motor tag, we have given the details of the limit switches related to them. First, the motor M1 is connected to slave number 5 and M1's clockwise limit switch is connected to the input pin 0 of slave 6 and it is triggered in the negative edge. Then counterclockwise limit switch is also connected to slave 6 input pin 1. Then we have considered the M2 which is connected to slave 6. M2's limit switches are also described in the same way as previous. In an emergency situation, output pin 0 of slave 6 should be high and output pin 1 should be low. Next, the emergency brake of the system is connected to the input pin 0 of slave number 1. After that, let's see the emergency details of cluster 2. Emergency brake that we previously mentioned can stop this cluster 2. Here we have connected the output LED panel to slave number 6 and input switch panel to slave number 1. This is the GUI we have designed to verify the functionality of the system. Using this, we can do system boot, network synchronization, GPIO operations, and XML related tasks. Now, let's move to the demonstration. To measure the time synchronization precision, we use PC-based oscilloscope and probes are connected to timer interrupt output pins of slave 1 and 5. We have set the identical timer interrupt settings for both slaves to compare them. Screen record is shown in the top right corner of the screen. First, we are going to boot the system by sending the boot command from the GUI. In this step, master will send frames to verify the slaves and collect propagation delays between the links. It also configures the slaves using the XML file. Now we are showing the time synchronization, which is the main feature of the system. Here the GUI has the option to turn on and off the synchronization. When the synchronization is on, two waveforms are overlapped as shown in here, and when it is off, waveforms start drifting. The reason for this is when synchronization mode is on, master periodically sends its clock to slave devices and slave devices adjust their time according to it and compensate their internal clock errors. Here we have achieved roughly around 50 nanosecond precision among 3 slaves. When we calculate that value for 255 slaves, we get around 6 microseconds. Now we are going to show the GPIO operations. Under this, we are showing digital read and write operations. Each slave has 8 input and 8 output pins. Here, first 4 input pins can be configured as interrupt pins. Digital write scenario can be demonstrated by writing a specific pattern to specific slave. Once done, the pattern will be visible in relevant slave's LED panel. Here we have chosen the slave 6, since our LED panel is connected to the first 4 output pins of it. Likewise, in a digital read scenario, input of a specific slave can be read from the master. For the demonstration, we are getting the input from slave 1. Since our emergency button is connected to the first input pin, switch panel is connected to the next 4 input pins of it. Next scenario will be motor driving. Our system is capable of synchronizing motors within a particular cluster. According to the user-given angle inputs, master will generate synchronized motion profiles and then the slave devices will issue the pulses according to those motion profiles. We are going to demonstrate this scenario by drawing some geometrical shapes. Next, we are going to demonstrate how our system handles different emergency situations. We can define different emergency levels according to our clusters. For an example, we can set emergency for predefined group of clusters and for a specific cluster simultaneously. In the demonstration, the main emergency button is capable of handling emergency for both cluster 2 and 4. The limit switches are connected to cluster 4. To indicate the emergency situation, we have used a separate mounted LED to the I/O card. In the first scenario, we are going to handle emergency for both clusters. When we push the emergency button, all the 3 slaves will move to emergency enable state. That will depict by the red LEDs. Also, you can see once the emergency enabled, 2 motors in the same cluster have stopped. Output pins of slaves can be configured to switch to predefined state in an emergency. These configurations are stated in the XML file. In our case, pin 0 of slave 6 will go to high state and pin 1 will go to low state in an emergency. Before pushing the emergency button, pin 0 is in low state and pin 1 is in high state. When the emergency button is pushed, pin 0 of slave 6 goes to high state and pin 1 goes to low state, and this is indicating in LEDs. In the second scenario, we are going to demonstrate a situation where limit switches get triggered. We have configured all these limit switches in the same cluster. In such a scenario, the emergency should enabled only for the relevant cluster. Here you can see the red LEDs are turned on in slave 5 and 6, which are in the same cluster. As slave 1 is in another cluster, that emergency is not applicable for it. In the third scenario, we are demonstrating how the system handles a broken situation. Here the emergency is handled in 2 ways. Once a link gets disconnected, the slaves in the link from there onwards will call emergency locally, as they have no connection with the master anymore. Slaves in between master and disconnected link will get an emergency from the master. To demonstrate this first, we are going to disconnect the link between slave 1 and 6. You can see the slaves are going for emergency enable state. Here slaves 6 and 5 will call their emergency locally, while slave 1 will receive emergency from master. Next, we are going to disconnect the link between slave 6 and 5. Here also slave 5 will call its emergency locally, while slave 1 and 6 receive the emergency from master.